Welcome to qnawire.
All right, so we have a concave mirror with a curvature radius of 12 centimeters. Our object is 3.3 millimeters tall, and the object is located at 15 centimeters to the left of the object. The first question asks for where is the image located. So we can solve our trusty equation, 1 over s plus 1 over s prime equals 2 over r. So what I'm going to do is I'm going to solve this for s prime by first moving 1 over s over. So we get 1 over s prime equals 2 over r minus 1 over s prime. Or sorry, 1 over s. And then we can get that 1 equals 2 over r. So the quantity of 2 over r minus 1 over s times s prime. So s prime equals the quantity 1 over 2 over r minus 1 over s. Now we have r and s, so we can plug our numbers in. Remember, r is our curvature radius, 12 centimeters, and s is our image location, which is 15 centimeters. And we get that this s prime will then be 10 centimeters to the left. And that will be 10.0 in significant figures, 10.0 centimeters. Okay, the next part of the question asks, what will be the size of the image? So we know that m, the magnification, equals y prime over y, where also that will equal minus s prime over s. So we have s prime as 10 centimeters and s as 15. So we know that, so I'll write that again. So m equals minus s prime over s, which also equals y prime over y. And that we have 10 centimeters over 15, which equals just 2/3 or 0.6666 repeating, right? And then so we can solve for y prime by saying y prime then will equal, so if I just move this over, so this is equal to m, right? So m equals 10/15, which equals 2/3. It also equals minus s prime, y prime over y. So then if I move my y over, so I get y times m, and I plug my numbers in. So this is 2/3 times y prime, or times y, sorry, y was 3.3 millimeters. So this will then equal a minus 2, sorry, this is a minus s prime over s. This is minus 2/3 minus 2/3, so this is equal to minus 2.2 millimeters. So our object is located at 2.2 millimeters, or has a size of 2.2 millimeters, sorry, and it's negative, so that image will be then inverted. Next part of the question asks, what happens if we then flip the mirror over? So it becomes a convex mirror. The only really thing that changes is that our curvature radius then becomes negative instead of positive, right? So our curvature radius becomes negative 12 centimeters. Our s stays the same. Our y stays the same, so the size of our object. So if I just recall back from using this same equation here, where we haven't plugged the numbers in yet. So we got S prime equals 1 over the quantity of 2 over R, which equals 1 over, now this is R, so it's minus 6, and then that's going to be minus 1 over 15. All right, I'm going to just recall, so S prime equals 1 over the quantity, 2 over R minus 1 over S. So 2 over R minus 1 over S. Okay, so R then is minus 12 centimeters, so I plug that in, so we get 1 over minus 6 minus 1 over 15. So our S prime then becomes negative 4.29 centimeters. And then that is, because of this negative sign, that's to the right. All right. So again, then we're also asked to figure out the size of the image. So again, M equals S prime, so negative S prime over S, which also equals Y prime over Y. So using this S prime, we can get that M equals 4.29 over 15. So that will give us 0.286. All right, so then if we use this M in this equation here, we can solve for Y prime. So Y prime equals Y times M. And then we can get that Y prime equals, if we substitute our numbers in, so 3.3 millimeters for Y, 0.286 millimeter, or 2.86 is useless. For M, we get that Y prime equals 0.944. Now the units of this, now this is important because our radius and S was in centimeters, but because they're divided out, that unit cancels in the magnification. So we're left with the unit of Y prime. The unit of Y prime is in millimeters. So this is 0.944 millimeters. And again, it's 944 because we're given 3 significant figures. So 3.30, 12.0 centimeters, and 15.0 centimeters for S. All right.